Hi sweeties! For today's video, we're going to talk about quantiles. When we talk about quantiles, this is score distribution where the scores are divided into different equal parts. There are three kinds of quantiles. First is the quartile, next is the decile, and lastly is the percentile. Quantiles give some information about the shape of a distribution, in particular whether a distribution is skewed or not. For example, if the upper quartile is further from the median than the lower quartile, we can conclude that the distribution is skewed to the right, and vice versa. As a result, a quantile is often defined as the value which has the p-th relative rank within a population, where the population is assumed to be an infinitely large set of different values. Implicitly, this defines p as the proportion of a set whose ranks are less than or equal to the p-th quantiles. So we have here the quartiles. Quartile is a score distribution that divides the score into 4 equal parts. Next is the decile. Decile is a score point that divides the scores in the distribution into 10 equal parts. And when we talk about deciles, it came from the word deca, which means 10. Next is the percentile. Percentile is a score point that divides the distribution into 100 equal parts. We have here the formula of quartiles, deciles, percentiles for ungrouped data. So you must remember that we have different formula for group data and for ungrouped data. First, let's talk about the quartiles for ungrouped data. So here is the formula. We have here the QK is equal to K over 4 multiplied by N plus the quantity of 1 minus K over 4, where our K is equal to the nth quartile, and we represent it as quartile 1 in N is the number of cases or our sample population. Next, let's talk about the deciles for ungrouped data. Here is the formula for we have dk is equal to K over multiplied by N plus the quantity of 1 minus K over 10, wherein our K is our nth decile and it represents the decile 1, decile 2, decile 3 until decile 9. And our N is our number of cases, just like what we have said in quartile. Next, let's talk about the formula of percentiles for ungrouped data. So we have here PK is equal to K over 100 multiplied by N plus 1 minus K over 100. Wherein our K is the nth percentile and it represents percentile 1, percentile 98, and until percentile 99. And our N is the number of cases. Do you think there is a similarities between the quartile, decile, and percentile regarding in this formula? If you say yes, let's take a look with this formula. So here is the formula for quartile, next is the decile and the percentile. If you said yes, that's nice, very good. They have similarities in regarding with this formula. They have the K, which represent the nth quantiles, and the N, they just differ in denominator. Because in quartile, its denominator is 4 because quartile divides the distribution into 4 equal parts. While in decile, its denominator is 10 because deciles divides the distribution into 10 equal parts. And percentile, its denominator is 100 because percentile divides a distribution into 100 equal parts. So let's take a look with this example. Using the given data 6, 8, 10, 12, 12, 14, 15, 16, and 20, we're going to find the quartile 3, decile 6, and percentile 65. we're going to apply the formula that we have discussed earlier. And in this example, our n, or our number of cases, is equal to 9 because if we're going to count the given data, it is equal to 9. Next, let's compute the quartile tree, wherein we're going to use the formula. So qk is equal to k, and our k would be 3 over 4, and our n would be 9, plus 1 minus 3 over 4. And if we're going to calculate this given problem, we get 28 over 4 score, or if we're going to divide the 28 divided by 4, we get 7 score. So in this data, our 75th of scores are less than 15 or equal to. Let us remember that in quartile, the quartile 1 represent the 25%, the quartile 2 represent the 50%, and quartile 3 represent the 75%. So therefore, if we're going to conclude, or if we're going to the 75% of scores are less than or equal to 15. Next, let's compute the decile 6, and here is the formula. Our k would be 6, and we write 6 over 10 multiply it by 9 plus 1 minus 6 over 10, and if we're going to calculate this, we get 58 over 10, and if we're going to divide 58 over 10, we get 5.8 score. Since the value of decile 6 lies within the sum of the 5th score and the 80% of the difference between 6th and 5th score, and our 5th score is 12 and 6th score is 14. And if we're going to calculate the value of decile 6, we're going to add the 5th score plus multiply it by 6th score minus the 5th score. And our 5th score is 12 plus 0.80 multiply it by 14 minus 12, and we get 13.60. And if we're going to interpret this, the 60% of score are less than or equal to 13.60. You must remember that in decile, the decile 1 represent the 10%, decile 2 represent the 20%, decile 3 represent the 30%, until decile 6 represent the 60%, and decile 9 represent the 90%. Next, let's compute the 65th percentile, and here is the formula. And in this data, our k is equal to 65. So we write 65 over 100 multiplied by 9 plus 1 minus 65 over 100. And if we're going to calculate this, we get 620 all over 100. And if we're going to divide it, we get 6.20 score. In this data, the value of 65 lies within the 6th score and the 7th score. So the value of 65 is the sum of the 6th and 20% of the difference between the 7th and the 6th score. Where do I get the 20%, or just like earlier, the 80%? We get it in the decimal that we get in the 65 percentile. So we have here the 6.20th score, or we get the 20 here, and we represent it as the 20%. And if we're going to calculate the value of 65, value of percentile 65, the 65th percentile lies within the 6th and 7th score. So the value of 65th is the sum of the 6th and 20% of the difference between the 7th and the 6th score. So where do we get the 20%, or the, just like what we have said earlier, the 80%? We get it in the decimal that we compute in those quantiles. So in this 65th percentile, we get 6.20, and the 20% in the decimal wherein we have here the 0.20. And if we're going to calculate the value of 65, we're going to use this formula. So the 6th score plus 0.20 multiply it by the 7th score minus the 6th score. And our 6th score is 14 plus 0.20, and our 7th score is 15. So 15 minus 14, and if we're going to compute it, we get 14.20. And if we're going to interpret what we have computed, we get 60% of score are less than or equal to 14.20. See you, sweeties. Thank you for watching.